you reckon I need power on my computer?
Right. On the steady cam,
You're just going to hold it.
I forgot to bring me little
Oh,
tripod.
that's good. I'm happy about that. Tape. You need some tape. Probably some gaffer.
Yeah, where's the gaffer tape when you need it? So maybe one thing I want to stop.
Here's fancy blind cards.
Yeah, the main one. Yeah, but it needs a wall. But I have noticed,
Oh, yeah. That's a pass.
why can't I have the radio? They said this icon is too long. Yeah, well, you positive from your PS. Yeah, so now what you need, but then it says something about if you have another wire. Because they give you, like that, two wires. So if I run that from the power supply. Still has to be another. From your manual, that's your internal, but then so that's the radio connection to the black box. The software, it says the SDR, when you're on the computer, it says general software. No, but which one do you do? Because there's a couple of different downloads. Yes, they are, yes. When you get your mobile, they are, is whatever it is. Then it comes up with a mobile, then it goes, the general software, another software. It comes up. And the core they give you on the panel. So what I've done is put an extension from the computer to On your Canada, you only have a very short wire over. Yeah, well, instead of doing, using I'm putting another extension to have whatever is in the computer, then the extension. Oh, just like an extension cord. Instead of having the SDR, you should nothing kind of very much in the yes, where you actually don't goes in the computer. I have it on here. The answer machine was on a house, cutting these sounded like it. And I run back again, give me my house number. They're not gonna come some price. No, yeah. I can see you, I just got one here. It's got your watch now.
But if you really need to use the you don't really send a text.
No, we're doing that. Yeah. Just pick it up from.
Really.
Well, because you're in.
Do go out on our own.
Yeah, I find the comments.
And this is I used to trade. Doesn't make any sense. The other one goes in the front. And the student wants to go. I have $13 in one, and you can buy two. You know, it's gonna try and 2 months.
Yeah, no, they've got, you look up. It's just. New Tahoe. Yeah, they've got a place like Tahoe, love them. Not right on the water, but they're very close. It's beautiful up there. Yeah. Yeah, they did. Yeah, so that's the regardless.
Nostalgic and
Better than LA.
The usual welcome to any new members or guests. Do we have any?
Yes, an old member.
Good to see you here, George. Good to see you here.
Yeah.
They've also got another one here, an ex-member.
Everybody knows you, and I've seen a lot of people talking to you, but welcome back anyway.
Welcome back.
Hello. That works really well. Okay, so I'll get through this as fast as we can and get on to the interesting stuff. So you may have received an email from me today about the last field day. Try that again. Amateur radio contest. Hello.
No, it's not the guy, it's YouTube.
Okay, now we got you. Okay, so the VHF UHF Spring Field Day is on the 25th of November.
And that's my suggestion, that we do that one up at Mount Cotton. It's a pretty good day. I enjoyed the last time we were up there. We can cover, I think, what's the highest frequency we can go to? Highest frequency on a UHF field day.
We can do 2.4 gigs.
Yeah, okay, so it's basically 6 meters to 2.4 then. And we can, as I mentioned in the email, offset the start, which Scott pointed out last time, which was useful, which means that we actually gain more points. So basically it starts at 11 o'clock, and then at 2 o'clock, they're in 3-hour blocks, and at 2 o'clock there's another block. You're allowed to start in the middle or wherever you want in the block. And so you can run over 2 blocks, as it gives you a chance to work everybody again. The only issue being that if we stay there too long, it's going to be dark and maybe a bit awkward in terms of taking equipment down. We can look at that. It's going to be pretty close to the getting towards the longest day of the year, which is going to help us. So you're talking, they can't fly that high, surely. So caravan and camping show, Eddie. Would you like to talk about that?
Okay, on Thursday, I think it was, Steve got a phone call. Can you put it on the display? So we came down on Friday afternoon, got our passes, and Saturday, Steve and I were down here, squeezing through the corner of the rail just out here and a caravan that had the windows propped open and all sorts of things. I think I had about 7 foot to get through on a bit of a turn. And we sat up over here near the blacksmith shop, and we ran from, well, we were set up before 9 and ran through till just before 5. We couldn't get out with the vehicle anyway until nearly 5:30. And we had half a dozen or so people turned up to have a look at what we were doing. I wandered around and had a bit of a look and was talking to a four-wheel drive group, and Steve and I will go there and give them a talk sometime soon. So overall, it was quite good. I bought a map of my four-wheel driving escapade, and that helped when I was explaining some of the stuff to some of the people that came to the counter. So all told, it was a great day. The museum were flat out. There was a queue out here for the food from virtually 9 o'clock till 4:30. They ran out of food on Saturday. That's how bad it was. And they were only one food outlet. But there was a sea of caravans out here. But a great day, and we had a good go at it, and the museum were happy we put on the display.
Well done, Eddie. And next we go to the fundraising and a few other things. That's Phil.
Yeah, thanks, Colin. And just to say, we got a nice email from the museum thanking the club very much, or thanking you very much for the work you did at the show at the weekend. So, Eddie, where are you gone to? Over there, yeah. So thanks very much, Eddie, for that. Just 4 things from me. We've got the last fundraiser for the year booked in for Sunday, the 9th of November at Bunnings Kapalabar. So we're looking for a roster of that in due course. Our club Christmas lunch is on Saturday, 2nd of December, not November. That's a typo on my behalf. That's the 2nd of December at Sporting Club. So everybody should be aware that it's 2nd of December. Bring a partner along, but we need to know numbers. So if you can email me, let me know. We'll book the numbers for that.
Thirdly, we've put the grant application in with the Gambia Business Fund. I'm glad to check it. We filed an application last week with the student. We've got $24,000 now spent on the museum training room and radio demonstration. So those funds are spent again now. So need a bit of work to do on that. So the museum's very keen to hook up and have a plan on what to do with that. It's a whole year project. And finally, for me, the sub-8 gas station. We haven't upgraded the software in the Flex. It went up there 3 years ago. We haven't upgraded it. Just to avoid everyone having to upgrade their own home software. But Flex had a problem last week, and it's forced us to upgrade now to version 3.5.9. That's now working. So if you do use the Flex, you need to upgrade your system. That's all from me. Eddie, I might get you to talk, or somebody else to talk about the RCC buildings, what we're planning to do there.
Did you go to the meeting on Friday?
Yes, I'm just trying to find the paperwork. Just a couple of things that Jeff's done a few notes on it, and he's done a pretty good job on the application. The thing I'd like to see is more about lower age group and the youth. He's talking late teens, it's early teens that we've had involvement with. I've done exams to people from 13 up, so we've got to come into that. And I think he needs to stress a little bit more on the females in our hobby. It's not quite enough of that. But otherwise, he's done a very good job with what he's written up. And I'll get on to him about those other two factors, because if we don't stress those sort of things in the community action that we do, we don't get the message across. But anyway, the buildings. I went to the viewing at Capalaba. We had a good look there. There was about half a dozen of us. There were 4 groups that came through, including us. We went to Victoria Point. There was a few less of us, but there were again about 4 different lots showing interest.
What kind of groups are they?
I don't know what some of them were. We couldn't get those facts out of the ladies that were showing us, but I do know Meals on Wheels were looking at Victoria Point. I happen to know because one of the ladies was my ex-neighbour. But yeah, there's competition there. But looking at Victoria Point, it's very minimal as to what we could do. We got no storage and there is no shipping containers. That was stressed. So it doesn't matter where you are. Maybe you could get away with putting a garden shed up, something like that. So that's something it needs to work through the council. Capalaba needed quite a bit of maintenance, but the council has a list. That's all the lady would tell us. So we don't know exactly what it is, but it does need a little bit of tidying up. But there will be some things that they will expect us to do if we were the lucky people.
Excuse me, is that one in Victoria Point? Is that the one on Link Road and Colburn Avenue?
Yes, the one right close where they've got the big ramp up.
Oh, right. Yep.
Yeah, it's outside measurements, 13 metres and just over 4 metres across. So by the time you take in something like about 4 inches thick on the walls, you start to lose quite a bit of room. And because it's only the one meeting room and one accessible toilet, there's no storage in there either, but you need some good curtains. Okay, so that's about it, I think.
Thanks, Eddie. And that concludes the first part. So it's on to the show and tell and this presentation by Scott.
Sure. Stand there.
I'll just on stand here.
I'll just leave that there, you reckon? Thing over, what are they called? QSL? 2 years ago. 1 second. Uh-oh. Come on, mouse. You can do it. Righto. Gonna have a look at some aeroplane navigation topics. Gonna jump all over the place, have a look at some charting, some history, some modern things, some aeroplane systems, some approaches, ILS, we'll have a look at these things, some radio options with air traffic control, and a couple other things along the way. Fire your questions whenever you like, or save them for the end, whatever you prefer. So the first thing to think about is what is navigation? It's not something you think about every day, but the three things I think is probably the most important one is where am I right now? Which it's impossible to get to where I'm going to go if I don't know where I am right now. So that's pretty important. We'll have a look at a few options for that. How do I get to where I want to be? Think about doing that in your car. There's a lot of different ways. You can't just go in a straight line in a car. And also, how could I do those things? How can I find out where I am right now? How can I get to where I need to be if I can't see? For example, it's dark, or it's cloudy, or you're so high that you can't see the ground, etc., etc. All problems that come up with aeroplanes, pilots. So the easiest way to move around is with dead reckoning or navigating visually. Dead reckoning also can be used non-visually, but we're talking now about if you can see something, you can get to somewhere else. So if I'm flying above Stradbroke Island and I know what it looks like, then I'll know where I am and I'll know how to get to Brisbane from there. This is the first thing pilots learn, how they're just to navigate visually with reference to things that are clear from the sky. We'll have a look at what some of those are.
Except if there's heavy cyclones.
Yeah, well, there's complications, right? Because you're doing it in 3 dimensions, which when you're on the ground in your car, you don't have that 3rd dimension. So it's a bit different. So dead reckoning is really just getting to a spot, knowing which direction to go after that spot, getting to the next spot, know which way to go after that spot. And that can be done with reference to visual landmarks or through navigation aids, which we'll have a look at later.
So it's got to start with those beacons up on the SOTAs get used, or?
Yeah, can be. There's all sorts of things. I'm just going to show you a chart now. So this is a visual navigation chart. It looks super complicated, but you don't need to memorize this for the test. But I'm going to show you a few things that make this good as a visual chart. You can see coastlines. The lighthouse at Cleveland is clearly marked. Golf courses are clearly marked because they're really easy to see. There's a helicopter landing pad there. Mount Cotton Mountain is marked. There's another golf course. What else? Things that are obvious. The smokestacks at the Port of Brisbane, not smokestacks, what are they? Like silos. The runways, the main runways, there's a race course mark, things like that. Things that are really the Gabba, shopping centres, yeah, those sort of things. Clearly marked. The Park Ridge Water Tower, things like that. So if you're,
Those lines are distance from the airport, is that where
these blue ones, yeah, 12 miles from Brisbane Airport. So Brisbane's here. What is this one?
Oh,
Can't read that one. That's 12. Everything's in nautical miles. That one's 15. The pink ones denote something different. Usually a danger area. Yeah, that's what the D is. And then what this means is that's controlled airspace down to 2,000 feet in that area. This one will be lower, 1,000 feet, and then, yeah, anyway, not going into controlled airspace tonight, but
So what's that 470 at the top there?
where am I looking? Oh, that's the altitude of a mast,
That's the antenna.
and it's lit. So see how it's a lit mast. Yeah, on St Helena Island, Fisherman's Island one is lit as well, and some of them are marked and not lit, like that one there. So these two beside it are lit, and that one in the middle is, you see, it doesn't have the shiny thing on it. So yeah, so they could be the things you see when you're up on Mount Gravatt or whatever. Where's Mount Gravatt? There's, yeah, Mount Coota. Is that one? There's Mount Coota there. All that stack there. And then, of course, waterways, lakes, highways, train lines, things that are easy to see. There's Amberley. Yeah. Yeah. So we're going to have a look at another chart in a while that's used not visually when pilots use instruments to navigate rather than what they can see on the ground. And you see it's the same. Yeah. Looks a lot different. Right, so back in the 30s when planes started to move around, they also started to have accidents. And these are some pretty famous ones in Australia. So you can Googleize these if you want to have a look. I'm not going to go into them. Okay, so Southern Cloud in the 30s in the New South Wales Snowy Mountains crashed because of bad weather. The Stinson you've possibly heard of. If you've ever been to O'Reilly's, there's a replica of that plane that crashed there in the car park at O'Reilly's, which was found by one of the O'Reilly guys. Again, bad weather. The Kiama in Victoria, I believe they looked out the window, thought they saw Sunbury, for example, don't know exactly the town, but it was actually a different town, and subsequently flew into the side of a mountain. So, and at the same time as this, radio techniques were developing in general around that time. Same all over the world, but specifically in Australia, this is how one of the things that started the need for more navigation tools available to pilots and an air traffic service or a radio service to start with, which ultimately became an air traffic control system. I'm not saying this was invented in Australia, but this developed in Australia, it developed in other parts of the world at the same time and eventually became a system which everybody uses. I'm going to play you this little video here. The current phonetic alphabet that we use didn't come until 1956. This is a video from the 50s. I think it's a staged video, but it's from that era. You can hear some of the phonetic alphabet being used, which is not what we use now, which is quite funny. Hopefully the sound works. Play it.
Charlo, this is Transat, Dunbar, Jamaica. Charlo, this is Transat, Dunbar, Jamaica. Position 2153, Central Angle down. Visual in the free airspace. Estimating flight goal 2235. Over. Dog Roadmaker, this is Charleville. Your position 2153. Langlow Downs, visual in the free airspace. Estimating black hole 2235. No damage force black hole. Men and equipment working on the 270 runway. Over. Dog Roger Baker.
Dog Roger Baker. Yeah, look up the old phonetic alphabet if you're interested in that. It's fascinating. Anyway, so that's an example of just a basic. It's not really an air traffic control service, but pilots would just call in with their position. See, the guy wrote it down, and he's just taking information really, and providing information about what he might find up ahead. LFR is one of the first radio navigation methods that was used. Not super popular in Australia, but it stands for low frequency ranging. And next picture will show it a bit better, but you can see that this, the transmitter, an AM transmitter, 50 to 1500 watts in low, under 1 megahertz, so below the normal AM radio broadcast band. It would transmit in 2 directions or 4 directions here. And it had a special use of Morse code, which I'll show you in a second. So define the airways of the time. What I mean by that is if you would know that that getting to this town, the easiest way if you wanted to use this nav aid was to come down this line here, and then there might be another one up here or down here, and you could make your way to these places by going to one and then the next one.
Is that the reason why they use AM, basically?
I think just this is from the 30s, so I think that's just all that was there at the time.
Modulation.
Yeah. So we'll talk about NDVs in a second, which is AM, and they're still using it. Yeah. So that's an antenna arrangement which would be used to create that sort of, effect. But what was clever about this system was that it used Morse code. And if you know your Morse code, this is an N and this is an A, and they would beam this up the line, up this line, and if you're a little bit off to the left, you would hear an N, darted, and if you're a little bit off to the right, you would hear the A, didar, and if you're right in the middle, they would come together, and all you would hear is a solid tone. You see how that works? Pretty clever. But that's high workload as well, so you'd need a radio operator who was sitting in the back, doing that. You wouldn't be able to fly and do that at the same time. But it would account for drift and things like that. Pretty primitive, but clever idea. The non-directional beacon is something that's still used today a fair bit. Again, it's AM in the similar sort of band below the broadcast AM band from the 30s, but still used today. A couple of different antennas. That's a vertical, I think. Don't see this very often in Australia anyway. Mostly what we see are these, it's like a dipole arrangement. You would have seen that sort of thing. I'm not sure exactly. It's got 3 elements there. So anyway, 1 single frequency, quite primitive. AM. This is what it would look like in the cockpit. You just dial up 1 frequency, so 323 kilohertz. Forget about that part, that's something else. And this dial, if it's in range of this, just simply will point at where the signal's coming from. That's it. Pretty rudimentary. Very simple, but quite useful and a step up from what people had before. So these vary a lot in power. Some of them are hundreds of kilometers, and some of them are only 20 k's away. You'll get them. So that detail is written in pilot documents as well. So they know they have to be close to some of them.
Just a question.
Yeah.
On the road into Bow Desert, there's a navigation device, which is a circle with like little cones. Is that
Is it really big, like 20 meters wide?
Yeah.
Next slide. maybe the next slide coming up.
It's a real one.
Yeah.
But the single antenna on the right has a capacitive top hat
Yeah.
that makes the antenna shorter.
Yeah. I'm guessing it's a vertical, and then with that hat. Yeah.
With that NDB, some of them you can tune into your radio station.
Oh, I was going to say that. Yeah, that's what I was getting to. Yeah, so you can hear this. They've all got an identifier in Morse code. So it's a DX opportunity here. You can, if the conditions are good, you can have a listen around, find a list of them, and see how far you can get with your AM. So this is one from Canada, which I didn't record this myself. This is just I found the audio for it just so you can hear what it sounds like. You hear a tone and you'll hear the Morse identifier. YAT. Yeah, and then just a tone. Yeah. So that's all you get from those. Yeah. Okay. We'll move on. More to come, and then we'll circle around back to this later. Distance measuring equipment. So there we have a piece of equipment which will tell us rudimentary which direction to fly maybe. But how far from that piece of equipment are we? That's where this piece comes in. Distance measuring equipment by VHF. That's one of the antennas there. And all this does is this device here, which is this guy, you plug in the frequency and it will just simply tell you the distance. So 35.2 miles from that beacon. That's it. You just get.
It counts down, obviously.
Yeah, if you're flying towards it. So this one's also showing speed, 102 knots, and we'll be there in 21 minutes. So it'll count down if you're going towards it, or counting away. Or if you combine that with one of these guys, you've got a somewhat effective way of knowing where you are, because I'm 300 degrees from that thing at 35 miles. I know I'm probably around here somewhere. So we're starting to get a picture together of where we might be. These are VOR. Is that what you're talking about? One of those? Yeah. Okay. So now we're getting into some more complicated arrangements. VOR stands for VHF omnidirectional range. Late 30s, up very much in use now. This is one type of antenna, but this is the most common one we see in Australia. It's about 28 metres across, I think, quite large installation. VHF, so the normal VHF rules for distance and line of sight apply. Up in the sky, we can get VHF to 200 miles, but, you know, as you're much lower.
Straight out of Doctor Who, doesn't it, the yellow thing?
Yeah, I don't know how any of it works exactly technically. I hope you weren't after that, because I don't know that stuff. I believe what happens with the VOR is you get an AM signal transmitted and an FM signal. It's sort of like a lighthouse beacon that rotates around through the degrees of a circle, and the device in the plane will decode that and give you a somewhat accurate representation of your distance, your direction from that device, and the radial you need to fly to get to it. So inside the plane, it looks like this.
So do these things automatically hop, or do the
No,
pilots have to
no,
change?
I'll show you that in a second as well. Yeah. So you have to plug in the frequency, and it's these are VHF. So I think they're just about. Oh, I've got it on there, don't I? Where was it? Just below. 100 to 112 megahertz. So this picture takes a little bit of explaining. That's the VOR there. This is our plane. And we've got dialed up on here, by turning this knob, we've got 070 displayed, and the opposite direction of that, which is 250. We're not quite on 070 though, we're a little bit offset to the right. So what the meter shows is that this bar here is that we're going the right direction, we're a little bit offset to the right. So that's showing us a lot more information than the NDB, which just was a simple needle with a pointer. pilots do a lot of training with this stuff, and they can get all sorts of information out of one or two combined. This is the same thing, but a little bit more complicated display. Some of them will show, this one will show ILS as well. We'll have a look at ILS later. Show glide slope and some other things too.
Tim, it's got in the modern planes, they have all vehicle stuff as well. Besides the analog belt.
Yeah. So this will display this, even though you might have a glass instrument, it's still connecting via VHF to the same instrument, but this is the display is different. So in a glass, what they call a glass cockpit, you might get 5 or 6 different instruments all displayed on one presentation digitally, but the information is still coming in the same way to the plane. The other thing it shows is to and from, which is this little flag here. So we are to this nav aid on the 064 or close to the 070 radial. That's what this little arrow means. As soon as we fly over it, that arrow will flip to the other side. It's giving us the same information, but we know we're on the other side of it because we're from the nav aid rather than to it. This is all complicated navigation stuff, which I'm not going to go into in any depth. I'm not an expert on that. We need some pilots for that. This is what a cockpit might look like, Marty. This is a small plane, Cessna 172 from his flight sim. So that's your NDB, what they call the ADF, Automatic Direction Finder, and 2 VORs. That's all flying stuff, and that's an engine instrument.
That's redundancy there on those two.
Yeah, redundancy, or you can use 2 at once. You can say, okay, I'm that direction from there, and I'm that direction from there, so I'm probably here. Yeah, and to dial them up, he's just here. So COM 1, COM 2, they're voice radios. Nav 1, Nav 2 are these. Nav 1, Nav 2. So just dial up the frequency there. And the information for that comes from charts, which I'll show you in a second. Or documents about the internet. That's your ADF, which is this, so transponder and some other stuff. But anyway.
So then autopilot looks at all that.
Yeah. So this, so one of these could be slaved to an autopilot. Yeah. Probably not the ADF. It's a bit rudimentary, but yeah, one of these could definitely be. And that's how it was done pre-GPS. These days, these are backup systems, and the GPS stuff is much easier. Yeah. But if you want to learn to fly and be an instrument pilot, you still got to learn all this stuff, even though you may not use it very often, except to stay recent with the skills. Okay, so excuse me. This is the same area of Brisbane we're looking at compared to the visual chart we were looking at before. So this is an instrument chart. It's called an en route chart. And you can see a very basic coastal outline. You can see the islands there and Brisbane, but there's no other features. There's no towns, no other visual features displayed, because once you're up in the air, it's not that relevant. So you can see air routes, you can see locations, Amberley Military, that's Brisbane, but mostly it's just navigation aids. Gold Coast VOR is there, Ballina has an NDB there. What's over there? Oki. The little green circles are aerodromes, whether, whatever size they are.
What's that Birkdale?
Where's Birkdale?
Is it there?
Birkdale, I think, is a radio transmitter for the air traffic controllers. So it's not a. Is that Birkdale there?
Is that on that site where?
No, Birkdale's in here somewhere.
Is that on that side where Douglas MacArthur lived?
Yeah. I think it.
Because there's a 4-story building inside that you
Yeah,
can't see it.
I'm pretty sure. So you've got navigation aids, and then you've also got a whole heap of radio transmitters where the air traffic controllers, when they push their button, it goes via Telstra lines or whatever out to that site and then transmitted from there. Yeah, so that, I think that's what's at Birkdale, but it's not my area, so I'm not sure.
That POR beacon is just below the Amberley.
Just south of here?
Down below the right-hand bottom corner of the Amberley block.
Around here somewhere?
Yeah, just down below the bottom right-hand corner.
Just here?
There, that's it. That's the one.
Okay, that's
on
Hugo.
the way out to Bodis.
Yeah, right.
It's actually retired now.
Yeah. Yeah, okay. So that brings me to another point, is that a lot of these things are being switched off and replaced with simple waypoints, pretty much. Yeah. So any of these 5-letter names, Hugo, Saneg, DB, Gommel,
So just visual way.
movie, they're just points in space, which is a lat long. Yeah. So I'll show you on the next one. This is my airspace, so it's a little bit more familiar to me. This is Newcastle, Sydney, Tamworth, Coffs Harbour.
Maybe tell the guys that you do that road remote from Brisbane.
Yeah, I run this airspace from Brisbane. So when I press my push to talk, it goes via satellite signal to Berrico, which is around here somewhere. It's not marked on this chart, I don't think. It's around here somewhere, up in the mountains in the Barrington Tops. And so there it is there, Berrico, Brisbane Centre 12055, that's me. And so when I press the button, it goes via satellite to that transmitter and gets sent out to that area. So I can't hear, if we've got a radio that could hear my stuff, we wouldn't be able to hear it here. But if you were sitting there, you would.
It's got to do with that. Do you get the little button, the uplink and downlink and so on? They pretty simultaneous.
It's instant, yeah. Yeah. Yeah, at least nothing noticeable. Yeah. And then I can also select secondary paths if there's a problem. So we've got 3 paths to the transmitter. Oh, well, I've got 2 paths to that transmitter. One via satellite, one via ISDN, I think it is, or whatever the replacement of that is these days. And then a third one, I can choose a different transmitter, which is at Mount Eaton, which is here, just by hitting a button. It'll just swap over to that. So when we get big storms, it knocks it out sometimes. We have to swap over. So in the old days, going back to Navaids, in the old days there'd be an NDB at Taree, Port Macquarie is still on there, West Maitland is still on there. There was one here at Mount McCoy, if you know Sydney, and Calgary. If you ever driven up the freeway near Calgary, the Calgary interchange is right here. There was an NDB there as well. So you might navigate out of Bankstown to that Navaid, then that one, 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 and go that way.
So in the old days, it had to be local.
Yeah.
Controllers. When did remote?
We used to have controllers in Sydney, but that split off in 1995. Now we're just in Brisbane and Melbourne. Yeah. But those, yeah, so you would have to make your way up, unless you were visual. Yeah, you would have to go from Navaid to Navaid. Now, in the last 10 years, say, closed down a lot of expensive to run radio gear and it gets replaced with just GPS air routes, really. So now if you want to fly to Coffs Harbour from Bankstown, you can pretty much just go straight there because the computer knows exactly where you are, which is my next point. Yeah, but if you had to get to Coffs Harbour from here, you might feasibly call up the Port Macquarie NDB and go straight to it, and then call up the Coffs NDB and go straight to that. Or if you were clever, you could call it up and work out, okay, it's there, I can go this way, and then recalculate it.
So on a private, they also using the same system.
Can do, yeah. Yeah. Yes, no, it's not, yeah, it's available. It's just a beacon sitting there. You can call it up and listen to it if you want.
Scott, is that for outside control airspace?
Well, the beacons will work anywhere.
No, but if it was in control airspace, it would legally just be.
Do what the controller tells you to do.
Yeah.
Yeah, but you still fly a route, so you'll still fly a plan. So your plan might be from Newcastle to Coffs Harbour, which would take you to Nicola and then Cadsey and then Coffs Harbour. And if I don't tell him any different, well, the clearance would be for him to fly to Nicola, Cadsey, Coffs Harbour. And if I don't tell him anything else, he'll do that.
Yeah.
So the controller's not giving any navigation advice unless they need it, or unless I need to move them for a reason like vector for time or vector for to separate from someone else or whatever.
If you have an emergency, then use to land.
Yeah, all that sort of stuff. Yeah. So if someone's stooging along here and they might say, okay, we've got a problem. Can you tell me the nearest runway that's got lighting? Okay. All right. Well, there's a runway right here, but it might not have any lights. Maybe Taree has lights. We can look all that stuff up and let them know. And you're 30 miles from Taree. It's in your, it's in your 6 o'clock or whatever. Yeah. Wasn't going to go into air traffic control so much, but that's cool. I like it. I could talk about it forever, so that's fine. Forgot what I was going to say.
So they're usually flying at least 2,000 feet or something like that, so at that altitude they've got no problems about hearing anything in that area.
Yeah. In fact, some of these numbers is the lowest safe altitude for that route, these ones with the arrows on them. If you're flying along this route in that direction, the lowest safe altitude is 5,500, which includes a lot of buffers. So 5,500 feet, which is how far?
They're going to hear a lot.
1,800 meters or something?
Is there a rule for them to get to that kind of altitude with a certain?
There are, yeah, there is, yeah. So, so with air traffic control, this is getting a bit more complicated, but we'll go there. The pilot navigates, or ATC navigates. 99% of the time, the pilot's navigating, and it's his job to make sure within 25 miles or 2 minutes, or there's some pilot rules, I'm not exactly sure what it is. He has to be up and established on this route and climbing up to these levels by a certain point in time. Yeah.
And then you guys monitor that? Or?
Yeah. Yeah. But if he's just flying along, then that becomes my job. Or if he's going down into an airport, that's my job as well. And I'll show you that later. There's specific ways we can make sure that they can get to the ground without hitting a mountain when perhaps you can't see any of the ground. Often you can't see any of the ground. So there's ways that you can get down. That's what we'll have a look at in a minute. So if I take over the navigation of a plane, for example, giving him a heading, I'll say fly heading 090. There's a guy going this way and a guy going this way, and I want to move him out of the way and go around the corner. Then I take over that, put him on the heading, let him fly that for a bit. Once they're out of the way of each other, then I tell him resume own navigation as an instruction. He resumes his own navigation. The pilot takes over again, and then he goes back onto his wherever he's going.
Does it normally deviate or change altitude?
Every situation is different. Yeah, yeah, yeah. Every situation is different.
And still use radar for that or some other technique?
Yeah. We'll talk about that in a minute as well. So all of this airspace over continental Australia, or most of it, especially around the cities on the coast, is all covered by radar. Once you head off the coast or into the desert, radar can fall off. We don't have 100% coverage over Australia. And then separation standards change. So I can get planes to about 5 miles from each other, which is still a long way. It's about 8 Ks. That's the absolute minimum for me. But if they're not on radar, that goes out to about 15 miles. And then if they're over the ocean, it could be 30, 40, 50 miles, which is quite a lot.
I know Russell does this a lot, but can any of them really fly under the radar?
In my airspace, most of it, we're good. I can see planes on the ground at Port Macquarie or taxiing at Newcastle. But at Taree, I lose them at about 4,000 feet. So it just depends on terrain. Just depends.
Scott, how far would the plane go? So if they go international flight, how far would they go before you lose them?
On radar?
Radar, yeah.
I'm going to show you. Can you ask me that again later?
Yeah.
Because I want to show you a map which shows that. there's equipment at Lord Howe Island. So if you're going that way, you're pretty well covered for a while.
Yep.
But if you're going to New Zealand, to the south, yeah, it's about 200 miles. And the radar would be at, if you know Sydney, in the foothills of the Blue Mountains, because it's up high, and that looks out over the east, over the ocean. So it's got a pretty good takeoff there. Yeah, King's Tableland, yeah. All right, we're back to Where Am I Dead Reckoning. Now we can do it, and we're supported by the NDB distance measuring equipment, a VOR, and also our visual. So we've got lots of different ways to do it if we can use all this equipment satisfactorily. A fascinating piece of kit that was invented in the 50s is inertial navigation. And what that means is a machine, like a plane or a spaceship, can, using accelerometers and a gyro, or a number of gyros, if it knows where it is to start with, it can fairly accurately work out where it is after it's been moving. And this was used and still is used in aeroplanes today since the 50s. But you've got to start somewhere. These days, you just plug the GPS in and it tells the INS where it is to start with. But in the old days, you would...
That's not the black box.
No, the black box is different. This is a black box. I'll show you a picture of one. It's fascinating. So this is a chart of Gold Coast Airport. And these are the gates here. Can you see my mouse there? So let's say I'm parked at 4L. I've got to tell the INS where to start because it has to have a reference point to start with. So this chart has all the coordinates for all the gates. It's pretty primitive, right? So I'm at 4L. I can plug in 28,955, 153.30, 38 into the inertial nav system, and it will know exactly where. Yeah, well, this is why you have cross-checking and all that sort of thing. Yeah, this is. I mean, it seems primitive, but it's also pretty advanced compared to what we were doing before. Pretty accurate, but it drifts over time. So if I'm working oceanic airspace, say from New Zealand to Australia, probably not a good example, America to Australia, and they're using this system, I can use, as an example, 30 miles standard between airplanes if they've reset this within 3 hours. As soon as it ticks over 3 hours, I've got to change that 30-mile standard to 50 miles because it drifts out of accuracy. Until then, they fly over a known point. So, for example, they fly directly overhead Norfolk Island. They could reset it with Norfolk Island's waypoint, or whatever, the lat long, and then they're good again for another 3 hours. This is all old, not done anymore generally because 99% of planes have GPS in them, and that just takes over. But this is what it looks like. This is from the Concorde. So it's a pretty amazing piece of kit. There's no surface mount components here. But what there are is, good luck to you, 5,000 trim pots. Oh. Look at this, all over. So who's calibrating that? I don't know. But it's a pretty fascinating machine. There's at least three gyros in there. Yeah.
Probably all retired now, so
no one would be able to do it. This is.
That's why the Concords are granted.
Well, for the time, right? It's pretty.
It's still one at Charles de Gaulle Airport.
A Concorde.
Yeah.
Yeah, I saw one in America somewhere. Where would I have done that? On the aircraft carrier in New York.
Just taxis all the time.
What's that called? The doesn't matter.
I rode in a Concorde a few years ago.
Oh yeah.
It was the windows are tiny.
Yeah, it's big. So back to this page, inertial nav. We could call it automatic dead reckoning via accelerometers. It requires regular updates from known positions to stay accurate. GPS is like a brand name. A non-brand name way to call it is GNSS, which is Global Navigation Satellite System. So that's what we call it. It's like an automated nav system, automating updates all the time, multiple times a second. You end up with absolute certainty of your position in free space with no landmarks, no lighting, nothing, no nav aids. It's what we're using now mostly.
What did you say the end in GNSS?
Global Navigation Satellite System. GPS is it's like tissues and Kleenex sort of thing. Yeah. There's only about 4 or 5 different kinds, I think, and GPS is a generic term now, but we're not allowed to use that term. Yeah. Yeah, so in all our documentation, we call it GNSS because it's not.
Well, different countries have their own. China
Yeah.
has one, Europe has one, Russia has one.
And now they've got a space treaty.
Yeah. Well, let's hope they don't switch it off because we rely on this all day, every day.
Well, they got rid of the selective availability, which I had a lot of.
It's pretty amazing how accurate this stuff is now.
Somebody might drop a nuke in certain parts of the world, so they introduced selective availability so that
Wasn't
you
super
only
accurate.
had a vague idea where you were.
Yeah.
But I think if they're going to drop a nuke on you, it won't make much difference.
No, it won't. Having different equipment means different ATC separation standards. It might. Every now and then we get a plane come through that's only got an INS and no GPS. It might be a freighter from Russia or something like that. And then we're going to get the book out and remind ourselves, okay, what are we doing here? Yeah. So.
Excuse me, Scott, when they go across the states.
Yep.
Straight across the ocean, the Pacific. When you lose radar contact, stuff like that, do they go straight onto HS or something? Or
I'm getting to that as well. There's a couple of different options for that. Yeah. Good question. So we'll get to it.
Yeah.
If you still have your question at the end, we'll go back there, but I think I'm going to answer that. Right, an approach. This is where we're talking about the safety of level and how if the clouds are at 1,000 feet and the mountains are at 3,000 feet, then how do you get to the ground without being certain of where you are? So an approach is a specific type of a navigation exercise with the goal of getting the aircraft below cloud, visual with the ground, and in a position to be able to land. And they are designed by airspace designers specifically for each location and for each runway at each location. So very, very specific, and that factors in terrain around the airport. Could be mountains, trees, towers, buildings, whatever. The idea is a plane can fly the published procedure in the dark, effectively in cloud, blind. And I'll show you some examples.
That must be scary for a pilot.
The first time, probably. First time. Have you ever been on a plane where it's just coming down and down and down? You can't, and you wonder. You just don't know. You feel like you've been descending for 45 minutes, and all of a sudden, and it's in the right spot. Yeah. Again, based on how these are designed, there's different levels of precision. I'll have a look at that. Some of them based on NDVs, not very precise. Some of them can result in an auto land, which isn't really generally used, but they do practice it occasionally. So it can be extremely precise. We'll have a look at ILS as well. I'll just go over it now. So while we're looking at this as radio nav aids. So an instrument landing system, is this picture clear enough? What it's showing is the plane in the black coming down, and it's getting 2 radio references. One of them is side to side, and one of them is up and down, known as the glide slope, which is the ping. And the purpose of that is to put the plane in a certain spot ready to land, both vertically and azimuth as well. Uses two transmitters. It looks very much like the VOR we were looking at before. in the cockpit, either as a display like this, or on the glass cockpit where the pilot's seeing it. Generally, the computer will fly it anyway. But this one, we can see that the pilot needs to go up a little bit and across to the left to center this to get in the right spot. So that's an instrument landing system. The GPS version of it, and it's becoming pretty popular now, is called GLS, which is the same thing, but instead of being based on radio nav aids, it's now possible to design a procedure based on GPS, which allows this much accuracy, and that is now the most it's the standard approach into Sydney now. GLS. They only do the ILS if they request it, if they can't do the GLS for some reason. Let's have a look at some charts. Got all that? No, this is complicated. This is complicated, but we're just going to look at some very specific things. There'll be questions later. Okay. This is the same place, Williamtown, New South Wales. We've got two different types of approach here. One of them is using the NDB, not super accurate. And one of them is using, it's not listed there, but this is a GPS-based one. And it's a little bit more accurate. They're both going to bring us around to land on runway 12 at Williamtown. But what I wanted to show you was, with ones that are not as accurate, I'll just describe what this picture is here first. These are altitudes. So by flying this approach around here, at this position, they cannot go below 4,000 feet. Once they move in a little bit, now they can go down to 1,300. And then eventually at this spot, they can go down to what's called the MDA, which is the minimum decision altitude. I think that's what that stands for.
Point of no return.
Well, that's the point where they have to decide, can I see the runway and land, or can I not? And it's the law that if they can't see it at that point, they've got to go again. So they go around. Now, using the NDB, the minimum descent altitude is 570 feet. If we use this approach, we can get down to 380 feet. So it's better, yep. If the cloud's at 400 feet, that one's not going to work at all, and this one might. So depending on the gear you've got, and what you're skilled in using, might make a difference whether you're going to get in or not at all.
So that's the older plane on the left.
Could be, yeah. Yeah, usually, yeah. NDB would not be used in anger these days. Nah, almost never. This one, 50 times a day. Yeah.
So when they're coming into land there,
Yeah, do you want me to? I can go over this a bit more if it's of interest to you.
pick cloud or something or other, he's just saying, I hope this machine's working right.
Yeah.
And at what stage does he say, I still can't see the bloody ground, where am I?
Yeah. So this one's easy to describe. This waypoint here called Whiskey Charlie, WC, then Whiskey India, Whiskey Foxtrot, and then the runway's here. So here, the computer does all this. He doesn't. You could fly manually, but the computer will fly to its waypoint, then to this one, then to this one, and then somewhere along here, hopefully you start to see the ground.
And if he can't see the ground,
It's the law. He's not allowed to land. But he can go down to 380 here, and it's different depending on your speed. Some of them, this one's the same, but some of them will have 4 different numbers here, and these numbers are based on your speed.
Do you guys have a history of what the cloud cover is normally?
Only through reports, not really. Or the guys in the tower might say the cloud's at 800 or whatever. Yeah.
So they don't land unless they can see the lights and they know it's land on the runway.
Yeah, and they've got to do that before this point here,
Yeah.
which is at 380 feet. So at Whiskey Charlie here, they can't go below 3,100. Once they pass Whiskey Charlie, they can go down to 2,000. Once they pass this point, they can go down to 1,300. And then they'll keep going until they're either visual or they get to 380. And at that point, they'll bail out if they can't see the ground.
Scott, I was on a plane that landed at Schiphol Airport in Amsterdam, and we could see right from as we started to go down a bit, that there was fog down there, just everywhere. And we landed. And
You couldn't really see anything.
Couldn't see anything, and the pilot said, ladies and gentlemen, you've just been landed by a computer.
Auto land, yeah. So that's not very common in Australia. I'm not even sure what the rules are around it. Occasionally we'll get a pilot asked to practice it, request to practice auto land, and then they usually practice it in good weather so that they've got a backup. But yeah, okay, that's interesting. Yeah. So when it comes to ILS, there's different categories of it as well, depending on the equipment installed at the airport. So there could be. We'll have a look at a couple of ILS examples as well.
Scott, some of the ones when they come down to land sort of thing, you get those really strong winds.
Yeah.
And over a certain area there, they come too low, then you've got to go back.
Yeah. So all of these calculations are based on things that are around the airport, and all these level things are based on that as well. This minimum height, once it's within this sort of area, that's a safe level.
That's all back in the stage. That's Windows update.
That's when you change your mind and go around.
What is that for? Yeah.
Yeah, it's updating
This is
Windows.
why aircraft don't use Windows.
That's right.
Scott,
Yes, George.
a pilot who's been examined for his instrument rating,
Yeah.
he's not going to be allowed to use a computer to fly the track, is he? He's going to do that manually?
I
in
guess
this
so.
day and age?
Yeah. Well, it depends on in a small plane, doing your IFR rating, yeah, instrument rating, you would be doing that yourself. But these big planes they generally don't fly them.
No.
Only when they land, they only land them really. Yeah.
Thanks.
It's coming. So, yeah, that safe level is safe within a few miles of, yeah, and there's a lot of buffers in there. So that was 380 feet. The highest thing is probably 100 feet, maybe, I don't know.
Oh, it's after that site.
Yeah, there's a lot of buffers. What? Do you want to do your thing while this happens? Yeah, come on. We'll have a pause. I've got a couple of slides left. It says your PC will restart several times. Okay.
This is a show and tell.
Yeah, hopefully. It's a also military versions of this stuff. They do their own thing. Yeah, so they depends on parts get the different. But a lot of random now. A lot of another example, camera. So here the elevation there is actually a lot higher, so it's the same concept. Starting at 5,000, depending on the depth out, about 506. But this little number in brackets is your distance above the ground. So it's really only 680 feet above the ground. That's a VLR on there. And that's based on the chart that's based on navigation by the VLR. That's 5 meters out. This thing is very 25 to 800 feet better using the VLR. One more example is this is the same problem in Australia where we have an ILS that's got only at one end of the runway. So you've got to land into wind. So your best approach option to get down below cloud, in this case 330 versus 510, but the ILS is only at one end of the runway. So if the cloud is low, but the wind is forcing you to land the other direction, that could cause delays or not be able to land. And if you swing around to the other end, use the ILS, you might be able to get lower and get below the cloud. So that's Brisbane, Melbourne, Sydney all have the ILS at both ends, but a lot of places only have it at one end, or not at all.
The Gold Coast, which end is
That's from the north, the ILS. So that's runway 14, I think. Where is it written? It's got to have the runway written on there somewhere. Yeah, runway 14. Over the water. Or down the coast.
over Currumbin Hills.
Yeah, that's it. Yep. Yeah, there it is there. Yep. Yeah. Yeah. There's a whole stack of information on these things. Pretty complicated chart. All right, one of the last things. A couple more things. This is a separate sort of topic. These guys here, precision approach path indicators, they're called. You'll see these on a lot of, most runways. Not this stuff is all separate, but we're just looking at this. When you're coming in on your glide slope, if you're exactly at the right slope, which is about 3 degrees for most, you'll see 2 whites and 2 reds. If you're a bit high, you'll see more whites. If you're really high, you'll see all whites. And if you're a bit low, you'll see 3 reds and 4 reds. Pretty simple system. Doesn't have anything in the aeroplane itself, which makes it pretty cheap and easy to install. There's something else I thought I'd show you. Yeah. Yep. There you go. These lights down here, I don't know what they're for. The green one is the start of the runway. And if you're landing and you want to know how fast you're going, these lights are every 60 meters, always. So you can count 10 of those, see how fast they go past. Yeah, yeah, from the cockpit you'll be able to see it from 20, 30 k's, 50 k's away, whatever, yeah, a long way away, yeah. When you go over the Gateway Bridge going north, at night, on the right hand side you can see the runway, and you can, yeah. On a good day you can see a lot of stuff there, but you should concentrate on the road. Just a tip. With ACC, I'll do this quickly. We use VHF primary where it's available, not available everywhere, and that's an AM VHF signal. We've talked about that before, if you want to go over that. But AM due to Doppler effect, I believe. because they're moving so fast. Yeah. VHF all the way for us. I have not heard any different systems anywhere. So it's pretty hard to change because it's global. Just the other night I was talking to a medical ambulance aircraft from Germany. What he was doing in Australia, I have no idea. But so you can't just install something in Europe because a lot of those planes are going to end up in America the next day or whatever. Yeah, so I don't know how they'll do that. HF is used outside of VHF coverage. It's all upper sideband. There's varying frequencies, and that gets updated to us throughout the day by someone else. I don't know who does it, but I'll get a message that says HF frequencies have changed to, it might be 13261 megahertz, and then later on in the day it might be 8867 or 3347 or whatever. Yeah, exactly. Yeah, but I don't take care of that. Someone else takes care of that. I don't do any HF communications. No air traffic controllers do. We have a team of people who run the HF radios, and it's all done through relay to them. So the pilot will call the HF operator and say something like, request flight level 390. That person says stand by, call us on the phone on a phone line. This pilot wants this. We go back, and it goes back to them through HF. So it's a pretty slow process. Not ideal, but as you know, HF has pretty good coverage most of the time. I don't do that, so I don't know specifically. I know doing my HF stuff here, we can get all around the world, so I'm assuming it's similar. Yeah. So the boundary is around Nauru. You know where that is? Honiara, Nauru. It's sort of halfway to Fiji. And so that's Australia's boundary with America. So that's an American service from there. So, but who knows? I don't know where their transmitters are. They might be in Fiji. I don't know. Could be. We'll have a quick look at CPDLC, which is the next steps on HF. When we don't have VHF comms, we use this thing called data link or CPDLC, controller pilot data link communications. It's our preferred method over long distance. It's basically text messages or instructions to and from the airplane, the pilot, and it's a digital mode effectively. It's like when we use FT8 or whatever, not the same of course, but that sort of theory in that if voice is noisy or not very readable, the data almost always gets through. You guys have used FT8 know, you can get a lot more. No, it could be satellite or it could be VHF. In Europe it's VHF, but most of it is HF, and there's about 15 stations around the world that cover it. That's enough to cover the whole world. I don't know much about the technicalities behind it, but I'll show you it in use. A lot of pilots will carry a satellite phone as an ultimate fallback, and they'll just call through to our office and talk to us that way. That's really cool. Yeah. How? Yeah. So this data mode reduces frequency congestion. That's one of the biggest problems, especially with HF. So if in Brisbane I'm using this frequency, and all my neighbours are not using the same frequency, but someone over the other side of the world is using the same frequency, there could theoretically be some interference, or you might hear some of their stuff as well. There's no doubt as to the message if it's done with data, whereas you could mishear something with HF. And probably the best part of it is it directly talks to the flight computer. So the pilot doesn't have to adjust anything on the plane. If he asks me for something and I say yes, the computer will automatically do it and the plane will automatically change. Which means less errors on my part and less errors from the pilot, which is 2 thumbs up. However, always VHF is preferable because it's immediate. If there's an emergency or whatever. The other problem is this stuff is only installed on, I'll call them the big guys, 7, 8 international stuff, 747, but you know, A350s, your local 737s and A320s get star and all that doesn't have this system installed usually. This is what it looks like on the plane. This is what a flight computer looks like, and so they'll be able to request from us an altitude or a whatever. This is an instruction from us. Proceed direct to this position. They can reply with Wilco, stand by, unable. Yeah. So instead of doing this by voice, I'll just text messaging. This is a clearance, clear to that place, runway 25 center, departing that, initial climb 5,000, sport code, blah, blah, blah. So a lot of information that would otherwise have to go by voice.
So they get sent that as well as voice.
Yep, both. Or it depends on where they are. So my stuff comes out of Sydney and goes to America, talks to Sydney Tower, Sydney controllers, then talks to me. I get them out to about 200 miles. And then they talk to guys who have a transmitter at Lord Howe Island. And then from there, they'll switch over to this system because there's no VHF coverage after that. Yeah.
So you're not sure where how this gets to the plane?
I'm pretty sure it's HF. Yeah.
Okay.
Yep. No, it doesn't matter. It's all silent to all of us.
Yeah, but I just want to know.
The manual for this, our manual for this is 450 pages long, so I can send it to you if you like. This is what it looks like on my side. So I get this box come up on the screen. It's from Qantas 43 at this time, and it says request climb to 370. I use a window like this to send my reply. So it's like text messaging, but with pre-filled out instructions. I say to him, climb to flight level 370, and he says Wilco. And as soon as he presses that, the plane does it. He doesn't have to adjust anything else. It's all goes straight into the computer. And that can be very handy. A simple climb instruction is not an issue, but if you get the complicated reroute, which might have 10 steps to it, getting that over HF and correct, it's tedious sometimes. It's pretty handy. Yeah, well, I can do free text as well. So a lot of this is grouping, so route, level, comms, weather, speed instructions, surveillance instructions, emergency. This is a common one. At position, contact Brisbane on VHF. So click on that, and then I've got 2 things to fill in. At a position, contact frequency, and then send it. And I'll get an instruction which says at Brisbane, contact 123.5. Yeah. So it's pretty handy. Use it a lot.
Does it go in so I know the message for?
Good question. I've got a video to show you.
You ain't close down
Please. Right, this is on the plane. Oh, can you see that? So look up here. You'll see the message flash, and you'll hear the alarm. So that yes, they do get a notification that we're. There it is. Message. And the message is contact whatever that is, 135.355, Barcelona control. And he's going to reply and say Wilco. That's it, done. Yeah. So pretty easy. Yeah. The computer does everything. Yeah. Well, any questions? Now, one more thing I want to show you, prove that they do exist, is I want to find the VOR antenna in Brisbane on Google Maps, which is up here somewhere. Could be that circle there. No, that's a windsock. There it is. There it is there. Yeah. They're quite big. 29 metres across. Anyway, any questions? Otherwise, I'm done. Thanks for your time. That took a while. No. Q&A. Got to Google that. Q&H is the air pressure, the area pressure. Because it changes the way an altimeter works. Yeah, it's measuring pressure, and its reference is based on nothing really. So what you've got to do is make sure, yeah, with the knob, yeah, and that changes the setting. Now, what it does is it matches you to other aeroplanes. So everyone's got to have the same. That's how it gets a reference. Have okay. B. Have okay is ceiling and visibility is okay. So that's a weather term. So ceiling would be the cloud height. Visibility is your horizontal distance. And if those two things are above a certain level, then you get a CAV OK report, which minimises the amount of data in a weather report. Yeah. So something like 8 kilometres visibility and 5,000 feet of cloud or something. I don't know the exact numbers, but if it's below a certain amount, you'll get specific reports of cloud and visibility. If it's above a certain amount, it'll just say CAV OK. So that's the
What about how does communication feel in terms of really say really get or something like that?
Sometimes only that we need to get a different path for the transmitter. That's all. Yeah, so if the satellite dish filled up, with water or something, or I don't know what happens, but sometimes it knocks something out and we've got to take a different path. That's it. That's not usually a big deal. Well, in my airspace, there's no local controls on the ground, so it's up. Yeah. So, yeah, we've had a few. Or I do the between Sydney and out to the east, so New Zealand, Fiji, America, all that. So we often get things like medical emergencies on board, or when you I've never had that myself. I've had guys forget to descend, so they're just like they're going into Port Macquarie and completely fly over at 15,000 feet. And like, what's going on? And he was like, oh, I forgot. That's pretty funny. I have had minor